Hi, it's Alan from Crashtest Security. In this video, I will tell you more about dynamic application security testing. So let's get started. Dynamic application security testing is becoming an integral part of the software development lifecycle. This type of application security scanner is not aiming to completely replace application penetration testing, but rather to enhance the security and compliance development process. DAST tools typically have no access to application source code and are primarily used to simulate external attacks. DAST tests are written by ethical hackers to attack the application externally by checking for critical flaws and potential security vulnerabilities on exposed attack surfaces. These experts then gather information on the application's security vulnerability depending on how it responds to these simulations. While DAST is performed on running code, it doesn't have to be necessarily done on production instances. These tests are often performed by QA analysts in simulated test environments to gather insights without performing simulated attacks on the running application on production. DAST is categorized as a black box security testing approach to uncover potential security issues. DAST has a better false positive rate than other application security testing tools. DAST helps organizations identify key runtime and exploitable web application vulnerabilities that were missed during code development and verification. Such tools also demonstrate the application's response to an attack, which is what most external attackers exploit to gain more control. A DAST mechanism offers several benefits to organizations, including continuously identifying new attack vectors that can compromise system security, an optimum approach for testing API security, detecting security governance and compliance requirements that may also include self-reported runtime vulnerabilities, obtaining insights of application performance and resource consumption, and lower false positives. Dynamic and static application security testing are two AppSec technologies that utilize unique approaches to identify weaknesses and potential vulnerabilities. There are differences between those two testing mechanisms. SAST uses a white box approach by leveraging the elemental source code and performing internal scans while the code remains static. DAST, on the other hand, uses a black box testing approach, where the tester discovers an application's vulnerabilities from an external ecosystem during application runtime. SAST tests for application source code vulnerabilities, while DAST tests for runtime and environment issues. DAST is used to evaluate security risks in web apps, databases, servers, and services, while SAST is primarily used to assess the application architecture and design environment, mobile applications, and real-time systems. DAST tools are widely adopted to scan web applications for exploitable vulnerabilities due to a number of advantages. They are platform independent and can be used to test applications independent of their hardware, design, internal architecture, or programming language. DAST tools can efficiently pinpoint configuration issues at runtime and identify memory consumption and resource usage. By simulating the movements of threat actors, DAST helps identify issues that may have been missed by development teams in earlier stages. It also scans efficiently for web API threats. While the advantages far outweigh the limitations, there are some commonly known challenges of using a DAST mechanism. DAST scanning offers limited scalability to simulate attacks at a larger scale, and it lacks visibility into an application's codebase. DAST combines vulnerability scanning with penetration testing to assess the security posture of an application in a running state. To do so, DAST tools typically inject faulty code and configurations into the application to detect and identify known security vulnerabilities. The following section explores how organizations can include a DAST scanner into the right stages of a software development lifecycle to ensure that real vulnerabilities are identified earlier than they get exploited, without employing the very pricey manual penetration testing approach. A common approach to DAST testing relies on a centralized registry of common weakness enumeration and common vulnerabilities and exposures to cross-reference and validate the severity of the susceptible points. These tools typically scan the HOM and HTTP interfaces for common security vulnerabilities, then perform automatic penetration testing for any exposed surfaces. A report of these vulnerabilities helps teams to update the application with patches for the vulnerabilities identified, improving application security. Successive DAST requires a security team with extensive knowledge of web servers, traffic flow, and common vulnerabilities to write tests and refine the testing approaches. Since DAST examines dynamic runtime environments, it is usually sensible to introduce the approach once the code has been developed and verified. DAST tools are commonly deployed when the application is going into production. Identifying weaknesses that threat actors can exploit and then illustrating how these flaws can be used for unauthorized access. DAST explores various attack scenarios and techniques used by attackers to gain access to web applications. Vulnerabilities and attacks uncovered by DAST include cross-site scripting, injection errors, and server misconfiguration. Cross-site scripting, a client-side vulnerability that lets the attacker include malicious code on a legitimate web page to execute malicious actions on a victim's web browser. Injection errors, malicious actors, disguised as users, use injection flaws to send untrusted data to web servers as part of a command. Injection attacks are often aimed at various targets such as SQL, LDAP, and XPATH queries. Server misconfiguration. In these attacks, the threat actor attempts to exploit weaknesses in the configuration of web server components. There are a number of existing DAST platforms that make it easy for any organization to get started on dynamic application testing. This section explores the factors to consider when selecting a DAST platform and some of the popular DAST solutions. DAST solutions vary in the scope and capabilities they offer, resulting in varying flavors and pricing options. Here are a few factors security teams should consider when looking for a DAST platform. Scan frequency, application target, end users, API security, deployment model, and single-page application security testing. Scan frequency. DAST tools offer various options when it comes to the scanning frequency and duration. CI/CD automated scans integrates security testing into the DevOps pipeline, leading to quicker detection and remediation. Scheduled scans, automated scans between set intervals. Manual scanning. Scanning is initiated by a member of the team on scheduled times. Application target. While DAST performs scans on running workloads, the tool can be used to target applications both in production and pre-production environments. End users. DAST are refined depending on whose responsibility it is to scan for weaknesses. They could be built for security analysts, engineering teams, or both. API security. DAST platforms that support API security testing are suitable for modern applications since APIs are increasingly becoming a threat vector. Deployment model. DAST solutions can be deployed on-premises or as SaaS options in the cloud, with different benefits for different use cases. Single-page application security testing. Single-page applications require a DAST that interfaces with a static document object model to identify the various paths on which the tests are run. Try Crashtest Security today to discover how it integrates into your development stack for efficient, automated vulnerability scanning. The trial is free. Also, subscribe to the Crashtest Security Channel to get more information about the most significant web security threats, their prevention, and how to use the Crashtest Security Suite. Thank you for watching, and see you in our next video.